Okay, welcome back. We're going to do this integration by substitution. We've got the integral from pi over 4 to 2 pi over 3 of cosine x over sine squared x. Okay, so again, we're looking for our inside function, and in this particular problem, the inside function is the sine, because if you'll recall, this is actually sine x squared. That's actually it. So the actual inside function is going to be sine x. So we're going to let u is sine x, du is going to be cosine x dx. So fortunately, I don't have to add anything to my integral. I don't have to add any constants. So I've got my u, I've got my du. Now I'm going to change my limits of integration. Okay, so since u is sine x, when x is 2 pi over 3, then u is sine of 2 pi over 3, which is square root of 3 over 3, square root of 3 over 2. And when x is pi over 4, u is sine of pi over 4, which is square root of 2 over 2. So those are my two new limits of integration. So now we're going to look at this again. So let's change the variables. The limit of its integration are going to be from square root of 2 over 2 to square root of 3 over 2. And cosine, that is du. And then this is 1 over u squared du. That's what I have. Okay, so now I'm going to actually integrate. This is u to the negative 2 du. So I'm going to do my little add 1 and then divide by that. So I get negative 1 u to the negative 1. And then I'm going to evaluate that from the square root of 3 over 2 minus the square root of 2 over 2. Yeah. Okay. So now a little help here, or a little trick here, is that u to the negative 1 is just a reciprocal. And that's kind of not always talked about, but that's what that is. That's just reciprocal. So when I do this, I'm going to have a negative 2 over the square root of 3 minus a negative 2 over the square root of 2. And that'll change to plus, because u to the negative 1 is just reciprocal in this case. So now I've got radicals and I've got fractions, and I'm like, oh, what am I going to do? Well, a couple of different ways to do it. I think rationalizing first is going to be your best option. I've done it both ways, where you add the fractions and then rationalize, and where you rationalize and add the fractions. So I think rationalizing is going to be the best way first. So I'm going to go ahead and rationalize this. So this gives me negative 2 square roots of 3 over 3. And this is going to give me plus 2 square roots of 2 over 2. And now to get a common denominator, I'm going to get a common denominator, and that's going to give me negative 4 square roots of 3 over 6 plus 6 square roots of 2 over 6. So my common fraction would be that over 6, and then of course that will reduce by 2. So it gives me negative 2 square roots of 3 plus 3 square roots of 2 over 3. So technically there it is, the final answer. The integration wasn't that hard. It was those fractions that got us at the end. But, go through the fact and reevaluate, rethink what we've done. Sine x was the inside function, and then the cosine x, and then we do change our limits of integration. and then we plugged in. And again, this little trick that u to the negative 1 is just a reciprocal. That will just save you a whole lot of headache when you're trying to calculate. And rationalizing was done first before doing the fractions, common denominator. All right, so that's it for now. Hope that helps. Let me know if you need any more help.